Hi everyone, this is our lecture on glycogen storage diseases. So let's get started. To get a clinical perspective, let's look at a quick flash case. A 9-month-old boy is brought to the pediatrician by his parents because he seems to flop over like a doll when sitting, and he used to be able to hold himself up much better. Additionally, he started crawling at 7 months, but seems weaker. On physical exam, his liver is enlarged. Let's keep this in mind as we go through the lecture. Our learning objectives for this lecture are to compare and contrast various glycogen storage diseases, distinguish the clinical findings of glycogen storage diseases, and to recognize the deficient enzymes of glycogen storage diseases. Okay, when we look at the summary of our metabolic pathways, remember glycogenesis and glycogenolysis here in the upper left play really important roles. So let's zoom in a little closer. Can you recall the rate-determining enzyme of glycogenesis? You're right if you're thinking of glycogen synthase. Well, what about for glycogenolysis? Well, you're right if you're thinking of glycogen phosphorylase. Now remember, the inducers of glycogenesis, or the creation and storage of glycogen, are the inhibitors of glycogenolysis, or the breakdown of glycogen into glucose, while the inhibitors of glycogenesis are the inducers of glycogenolysis. Make sure to pause and revisit the sections on glycogen regulation or the rate-determining enzymes if you're interested in more detail. Let's move on to the glycogen storage diseases. At least 15 types have been identified, and don't worry, we aren't going to talk about all 15, just the highest yield ones. All of them result in abnormal glycogen metabolism and an accumulation of glycogen within cells. Can you remember which stain is particularly good at staining glycogen? You're right if you're thinking of the periodic acid shift stain. It can be really useful in identifying these diseases. So to understand the glycogen storage diseases, we need to understand glycogen storage first. Now remember, in hepatocytes, glycogen, which is circled here, is stored and undergoes glycogenolysis to maintain blood sugar at appropriate levels. Labeled in red, you can see Roman numerals indicating which part of this process is affected in the associated glycogen storage disease, leading to glycogen accumulation. Now, when we zoom in on that last image, labeled in the red Roman numeral 1, we can see which step is deficient in von Gierke's disease, which is type 1. The deficient enzyme is this very first one in the diagram, glucose 6-phosphatase. We'll have an accumulation of glycogen and not enough glucose. So our findings would include severe fasting hypoglycemia, increased glycogen in the liver and kidneys, increased blood lactate, increased triglycerides, increased uric acid, which could manifest as gout, hepatomegaly, and even renomegaly. The liver doesn't regulate blood glucose, and so then treatment would be to have frequent oral glucose or cornstarch plus the avoidance of fructose and galactose. Von Gierke's disease impairs gluconeogenesis and glycogenolysis. Now the next glycogen storage disease is labeled in this diagram with the Roman numeral 2. This is Pompe's disease, or type 2. The deficient enzyme is lysosomal acid alpha-1,4-glucosidase, or acid maltase, with an alpha-1,6-glucosidase activity. Our clinical findings would include cardiomyopathy, hypotonia, and exercise intolerance. This glycogen storage disease is unique because it affects the heart, liver, and muscle. These systemic findings can lead to early death. One way to help you remember this is with the mnemonic, Pompe trashes the pump. Well, what pumps? Well, the heart, liver, and muscle. Also, the first and fourth letters are both P in Pompe and pump. But the 1 and 4 can help you remember the alpha-1,4-glucosidase enzyme as well. Next, we have Cori disease, or type 3, which affects the Roman numeral 3 in this diagram. The deficient enzymes are the debranching enzymes, alpha-1,6-glucosidase and 4-alpha-D-glucanotransferase. This is not to be confused with alpha-1,4-glucosidase we just talked about for Pompe disease, because remember, the P's in Pompe and pump are the first and fourth letters. This is why that mnemonic is so helpful, because the enzymes are really similar and literally just one number different. Our findings will be similar to von Gierke's disease, but there will be milder symptoms and normal blood lactate levels. This can lead to cardiomyopathy like Pompe disease. If you look at the diagram before this step, you'll see a limit dextrin, which refers to the 2 to 4 residues remaining on a branch after glycogen phosphorylase has already shortened it. These limit dextrin-like structures accumulate in the cytosol in Cori's disease. What is worth noting is that gluconeogenesis remains intact. The type 4 glycogen storage disease is Anderson's disease, and the deficient enzyme is the branching enzyme. Clinical findings include hepatosplenomegaly, failure to thrive, infantile cirrhosis, muscular weakness, hypotonia, cardiomyopathy, and early childhood death. And of note, the neuromuscular form can present at any age, whereas hypoglycemia tends to occur later in the disease. And lastly, we'll talk about McArdle disease, type 5, which affects the Roman numeral 5 in this diagram. The deficient enzyme is skeletal muscle glycogen phosphorylase or myophosphorylase. Physiologically, there is increased glycogen in muscle, but muscle can't break it down, so this results in painful muscle cramps, myoglobinuria or red urine with strenuous exercise, and even arrhythmia from electrolyte abnormalities. Very often we use the mnemonic McArdle and muscle to remember this is the glycogen storage disease with a lot of muscle effects. Additionally, there can be a second wind phenomenon noted during exercise due to increased muscular blood flow. This is characterized by a flat venous lactate curve with normal rise in ammonia levels during exercise. Typically, blood glucose levels are unaffected. So here's a summary of the names of the diseases, which numeric glycogen storage disease they are, and the deficient enzymes. In addition to the memory tricks we've already discussed, there are a few more. The first is Vice President can't accept money, which helps you remember the first letter of each disease in numerical order. Next, types 1 through 5 are autosomal recessive, so all the ones we've discussed are autosomal recessive. And lastly, ABCD. We talked about both a branching enzyme and debranching enzyme, so if you remember ABCD, A for Anderson and B for branching go together, as does C for Cori and D for debranching. Okay, that was a lot. Let's do a quick flash quiz. Which glycogen storage disease presents with increased glycogen in the liver and kidneys, hypoglycemia and increased uric acid, blood lactate, and triglyceride levels? If you said von Gierke disease type 1, then that's great. Remember, increased uric acid or gout also has a G in it like von Gierke. Try to remember the unique findings of each disease. Well, let's return to this case. This baby is floppy, which I know is triggering thoughts of some microbiology or jars of honey rather than biochemistry. But what could also make a baby floppy? He could have hypotonia or muscular weakness, as in Pompe disease or Anderson disease. We definitely need to get more information to limit our list of differential diagnoses, but this very well could be an enlarged liver due to the accumulation of glycogen in a glycogen storage disease. Well, we've made it to the end. What's the bottom line? There are at least 15 types of glycogen storage diseases that have been identified. Types 1 through 5 are von Gierke disease, Pompe disease, Cori disease, Anderson disease, and McArdle disease, respectively. And all of them result in abnormal glycogen metabolism and an accumulation of glycogen within cells. That's all I have for you here. Please give this video a thumbs up if you liked it, and it will give you the opportunity to submit a comment if you have any feedback or questions. Thanks for joining me. Study hard.